So you're officially on the recorded line. We are going to put the recording on YouTube, and I'm going to show you in a moment where all of that stuff in. All right, how many of you are new? Anybody new to the group? Anybody joining for the first time ever?
I am.
Me too.
Hey, Jewel, some other people. Where are you guys coming from? United States or far away?
Nope, I'm actually in Atlanta.
Atlanta. There we go.
I'm in Riverview, which is in the Tampa Bay area of Florida.
All right, Tampa Bay. Anybody? Anybody from other states or countries? It's not. So Tampa wins the award. Okay. So those of you who are new, our main site is on Meetup. I'm not sure how you were able to find us. I guess on Meetup or maybe my announcements. So actually we have two, not one, but two. So to have redundancy, we have two sites. One of them is on Meetup, the other one on Microsoft Power BI communities. But the main one is the Meetup one. And speaking on it, this is our website right here. So if you get some value, if you like our meetings, make sure you register to get notifications and all that cool stuff. Spread the word, invite your coworkers. Recordings, as I mentioned, we put them on YouTube, and the link is right here. So if you go there, this actually is going to point to YouTube. You're going to see all of our recordings for the past year or so since we decided to go virtual. Speaking about virtuality, so it looks like Microsoft is kind of opening their office, but now we have another problem that we don't have a blue badge anymore, somebody from Microsoft to let us in. So we have to be working on that and see who's going to be that brave soul that actually is going to stay once a month for our group. And once we figure this out, who knows, maybe we'll get back together in person, but for the time being, doing virtual thing. And even if we decided to do that, maybe we'll keep both on in person and virtual for some time. If you want to get involved, always looking for speakers. If you've got something interesting to share with the community, let us know. Let's not worry about the donations so far because typically we use them for speakers, but right now we're not meeting in person, so kind of took care of the donations. I like that. Let me know. Let us know. Actually, I forgot to mention that it takes a village actually to run this group. So though I kind of introduced myself in the very beginning, there are other people that help me, and some of them actually on this meeting. We got John. I'm not sure if Damu is here. Mark Tabladillo, who actually pays for the meetup group from Microsoft, and many others. So let us know, share a feedback in the chat window or outside if there is anything that we can improve. Always looking for feedback. The format of our meetings have been the same since the very beginning. I know sometimes actually this can get tedious, although everybody, those who are following us know the structure. But if you guys have any ideas, especially if you want to help us implement them, I'll be very actually interested. Jobs. Does anybody have any job openings? Is anybody looking for Microsoft BI talent that you want to let the community know? Anybody out there? Please feel free to announce it. Or, yeah, go ahead.
This is Michelle Jameson. I work with Fortna, and we actually just merged with MHS. My manager just informed me this morning that he's going to be looking for some BI talent as well as SQL. So and that's fortna.com. I can email you after or later.
Or you can
or
put it in the chat window. That's
Okay.
probably the best. Just
All
put
right.
a link. Awesome. Anybody else? I just want to quickly mention I have actually I have a client, enterprise client, one of the best well-known consumer groups company here in Atlanta that are looking for project managers, product managers, BI architects. They've got the whole thing on Microsoft Azure, the whole enchilada data warehousing and Azure Data Factory and whatnot. So they're looking for contractors because they can't find people. If you have experience in project management, product management, in the BI space, or if you a technical architect, BI architect, let me know, and I will introduce you. So, anybody else have any announcements? This is as far as jobs. I haven't noticed any events happening in near future. Has anybody have any announcements for news? Something that I miss? Anything coming up? I guess not. Well, the next thing on the agenda here is to talk a little bit about some new features that we have in Microsoft BI, Power BI specifically. And some of them actually I'm going to show you. The first feature I'm very excited about. And the best way to understand it is to show you a demo in a moment. So I'm going to show you the field parameters. We have interactive reports in PowerPoint that I'm going to show you as well in a moment. Self-service data marts. So it so happened that I just wrote a blog about my opinion on data marts, but just to let you know. So imagine you in a big company, right? Does anybody want to say something? Okay. You're in a big company and you work for a department, let's say sales department or marketing department, and you want to build a data mart. Data mart, you want to import some data, put it into Azure SQL database and model it for your department, but you don't want to bother IT, or maybe don't even help. You can reach them. So now in Power BI, we have a new feature that got some attention recently, and we call them, what do we call it? We call it data marts. But you have to have a premium, Power BI premium workspace, either pay per user or premium. So then if you go to the new menu, you will see the feature right there called Data Mart. So what this allows you to do is to use data flows. If you're familiar with Power Query, which is actually a subject of this presentation, Power Query is getting omnipresent. And now you can actually use the Power Query online to import data from somewhere, transform it, and put it into a Microsoft provisioned SQL database. So Microsoft gives you a database for you. They say, oh, because you're so nice, you've got Power BI, I'm gonna give you a database. We're gonna manage it. We're gonna make it read-only, so you cannot do any fancy stuff in there, but we're gonna give it so I can put all the data from this data mart, this Power Query, so you can put it in there, and that's gonna be your department data mart. So I have some things that I like about this feature and some things that I don't like. As I mentioned, I just wrote a blog about it. If you go to my website, if you want to learn my opinion about this, the good, the bad, and the ugly. I'm not a big fan, to be honest with you, just like any other pure self-service BI features, for a variety of reasons. I personally would prefer Microsoft to extend Power Query to save the data in other destinations instead of putting it to a data lake. That would have helped a lot because actually IT and business users can work together. IT can provision a database and can say, oh, because we're very busy, some of the ETL, you guys can, the business users can do it. So that will, in my opinion, will give more flexibility than having kind of this red tape around this new feature data mart. But who knows, in future, maybe it's going to get more flexible. So keep an eye on Power BI data marts. Learn more about it. I'm going to show you a demo of this. although it's a very, actually might, if we have some time at the end. So we have that data marts, we have Canvas Zoom. That one is easy to understand. I'm going to show you in a moment. We have something called formatted tables. And the last thing that I want to bring your attention is that they changed the documentation, Microsoft, to have something, to have a list of known issues. So let's say something is not working in Power BI and you go and chase people, but you cannot find. You went to Power BI website, there are no outages. So that might be the other place for you to go, because that one, this known issues, gives you exactly what's wrong right now with the Power BI cloud. So it's kind of itemized, and you can just see what features are not working in the moment and what's the status. So you don't blame yourself, but you blame Microsoft. Okay, they are the blame. All right, so let's go and jump on some of these things that I want to show you here and see what we've got. All right. So let's start with this first feature called field parameters. In my opinion, this is a killer feature. So here is a scenario. You work on a dashboard. You work on a dashboard and you want to fit a lot of visualizations on the landing page. And to make the things more interesting, let's say a lot of the charts or visualizations are the same. The only thing that the users want to see is the ability to change the dimensions. So maybe you have a line chart that shows revenue by product, but they want to use the same chart. They want to do a little switch. And instead of revenue by product, now we want to show revenue by customer. So I want to reuse the same charts, the same visualizations, but to show different dimensions. Can we do that? What do you guys think?
Yes.
How?
With parameters.
Parameters. So previously we couldn't do this. So that actually feature, it was causing so much grief, and I've seen different implementations to get around it. Previously we couldn't do it. But now we have a feature called field parameters. So let's go and get started. Actually, it's very easy to implement. We're going to go to the modeling tab and we're going to create a new parameter. But now we have a new option called fields parameter. So I'm going to go here and I'm going to say, I'm going to select the dimensions. By the way, this also works for measures, but measures were not that problematic because I can have a wrapper measure, and depends on if the user wants to see year to date or quarter to date, I can change that measure dynamically. Dimensions were a problem because once you bind a field to a visualization, that was the end of the story. We couldn't actually control it with expressions. But now I could say here, I can go here and I can say maybe in the product, I want my users to be able to select class, color, and maybe a product model. And by the way, the attributes that don't have to come from the same table. I can go actually across tables. But let's say I want to allow the user to select what they want to see on the chart. What is the dimension to plot the measure by? So I do this, and by default, Power BI automatically is going to add a slicer, which is kind of cool. So let's go and click create, see what happens in here. So what happens in here is that we've got now a new table added to the fields, as you can see on the right side. It's called parameter. And we've got we have a column in that table called parameter 2. And there is a DAX expression behind it, which is very simple. It just says that it defines pretty much a list of the things that I selected. So the first argument returns the user-friendly name, what they're going to see in the slicer. And the second argument basically tells us what's the name, the fully qualified name of the field behind this name. Because I can call this class whatever I want, maybe product class, but the underlying field could have completely different name. And the third argument defines the sort order. How will these things actually be sorted in the slicer? And that slicer, as I said, is automatically generated. Cool. So now that I got that field parameter, let's go ahead and do something with it. So I'm gonna go and maybe from the reseller sales, I'm going to get, maybe I have a field here called profit. Oops, I did the common mistake that I had to click on an empty space. All right, so here we got a chart. So let's go ahead and also add the parameter field to the x-axis. All right. So here is the trick. Now it shows profit by class. But if I go here and change color, if I change it to color, now it shows profit by color. If I go to the product model, shows by model. Isn't that cool? That's really cool. So now what this allows us to do is to have, just to reuse the space instead of keep on creating charts. If these charts are the same, in this case, column chart, but I just want to plot different things on it, now I can do that. So I think this is very cool, probably the best feature that we have among the new features since the last time we met. So it's called field parameters. Interactive reports in PowerPoint. Now imagine you go to a meeting. You go to a meeting, I want to show a report. But copying the report as an image and pasting it inside PowerPoint, it's so 20th century, right? So we can do better. So let's see how that, let's say this is my slide deck in here, and I'm going to add a new slide where my report is gonna go, and I wanna add my report. So I'm gonna go to the insert menu, and what we have to do here is to install an add-in, which I already installed, but if you haven't, just go ahead and search for Power BI in here, and then you're gonna see this Power BI Tiles is from a third-party company. It's a little bit confusing. What you really need is the Microsoft Power BI add-in, all right? Because before we had that new feature, we had to use a third-party add-in. So they both work. They have different features. I haven't compared them. So install that add-in, and when you do that, you're gonna have a new Power BI button in here. So you're gonna click on that button, and it's going to ask you for the report URL, right? So how do we how do we get this report URL? Well, we are gonna go to, sorry about that. This is me. This is me. All right, so we're gonna go to Workspaces, and maybe we're gonna go and get the, those of you who have done Power BI dashboard in a day are gonna be very familiar with this report. So what we're going to do, actually, we're gonna copy the report URL. I don't think that we need to include the report section, which is the first page that is gonna be displayed by default. So I'm just gonna actually copy that URL in here, and I'm gonna paste it in here, and then we're gonna click insert. We're gonna click insert, and what do we have? We have the report right here inside PowerPoint. But what's even cooler is this report is interactive. So now I can really impress my manager. I can go to the meeting, I can say, okay, see what's happening here. I can even change slicers and filters, and the report updates. I did this yesterday. I spent the whole day doing this. No, that actually that's a built-in feature. So what do you guys think? It's a cool feature. Thumbs up. Anyone is successful reference it to a parameter in a custom chart title. Huh. Bruce is like, Amy is way ahead. She actually already tried that feature. Amy, I haven't tried that, but I will, and maybe let you know. PowerPoint export from Power BI has live data. How is this different? PowerPoint export from Power BI has live data. Really? PowerPoint, when you export a report to PowerPoint, live data, I thought that we embed an image in it, Bruce, but maybe I'm wrong. Who knows? propagating that stuff. You have both now. Okay. Cool. So we've got that Canvas zoom. Nice to have feature. Nothing terribly important here. Previously, there was no way to zoom in and out the Power Desktop Campus. Now we have a zoom, just like any other tool out there. I've worked in Excel. Now we have actually ability to zoom the canvas, which helps during design. Not a big thing. Formatted tables. Believe it or not, most report requirements call for dumping data, because users don't trust it. They want to see it. So now we have an easy way to create a SSRS report, paginated reports that has the data from one or multiple tables. So let's see how that works. I'm gonna go in here and I'm gonna go to my data sets portion and I'm gonna say, oh, this data set is very cool. And I wanna make it, so we have several options in here. If I do create report, it's gonna create Power BI report connected to that data set. If I create paginated report, it's gonna open the report builder where I actually can create SSRS report from scratch. But finally, we have create formatted table, which is this new feature, which actually makes kind of auto-generates the SSRS report from me. So for instance, if I go to the sales table and I say, okay, this is the columns that I wanna, this is the fields that I wanna see. As you can see, it auto-generates the format in here. So what I can do then, I can save this report. If somebody comes to me and say, I want to have a data dump of this data, and I want to be able to export it to Excel, PDF, Microsoft Word, Microsoft Excel, this is the easiest way you can implement it. Just put a SSRS report, and the feature is called formatted table, save it, and now they can go and see it, and they can export it. Behind the scenes, this is actually SSRS paginated report also called. Well, let's stop right here. Let's see, we got some meeting in here. PowerPoint export from PowerPoint live data. Okay, got something to add if you like. John, go ahead. You want to add something?
Sure. So yeah, so I've been, or actually my some of my employees at work that really want this feature, Power BI, in PowerPoint. So the question then becomes, because some of the other products out there, or at least one of the other ones I know of, where you're actually able to embed their visualization into PowerPoint, is what happens if you want just one slide, one visual in the in PowerPoint. What you can do is, there's two different ways of doing it. You know how you can do focus mode? So if you go into one of the visuals and you select focus mode,
Okay, sure.
then that's one way of doing it, right? The other way I found before I found out about that little trick was, what you can do is, which is not, it's a little messy, but it's cleaner, it's messier at the same time. If you copy, so if you open it, create another page, copy and paste one of the visuals, say on this page to another, and then what you can do is point to that URL and then make the size of the page a little bit bigger than the size of the visual. Then when you do the import for that, it'll be the right size and it looks clean. So those are just two
How
little tips.
do you copy the visual? Sorry.
You could do a control C, control V. No, you have to do it in Power BI, either desktop or online.
That's cool. Let's go and try that real quick. Okay, so that's
You have
the
to go into
data set.
edit. Yeah, you have to edit the.
Sure. So let's go ahead. Go in here. Wait for this to render. Click on edit. Let's say I want to copy this chart. I'm going to do Control C. And now I go to PowerPoint and do Control V.
Oh, no. You have to create another page. That's what I'm saying, in the report.
Oh, yeah. Another page, meaning like another Power BI thingy.
Correct, in PowerBI.com, or yeah.
I'm gonna call this here. Click Insert.
No. You're not doing this. So I mean, like in Power, you can edit in PowerBI.com to create another page on your report.
Oh, I see.
And then
So
Control
just
V
with
to
a
that.
okay. I thought that we can just copy directly the
No,
visual.
I wish. Yeah, that's not. Yeah.
Actually, I'm very curious because each one of these visuals actually has a link behind it. That's why
Mhm.
when you add it to a dashboard, the dashboard knows which visual you pinned. So
Right.
I'm very curious actually if we find that visual URL and if we go ahead and plug it in here, you know, when you go and create that, if that's going to work. But that's
They're
a very
going
good
to. That's
tip.
going to be a feature shortly. They're going to add a feature where you can just import one visual.
Okay,
That's coming. So not at this point.
awesome.
Okay.
That was great.
Sure.
So Annie is asking here, do users need to have access to the workspace in order to view the formatted table, or can app users view formatted tables as well? Yeah, so this is going to become, once you save it, Amy, that's going to become a report, just like any other report. So all the Power BI permissions are going to apply at that point. So either they have to be a member of the workspace, or you have to go and create an app and publish that report, right? So from that point, the report security actually will take over. Cool. Any other questions? Yes, not. And we're about on top of the hour. Time to start the main presentation. So what we're going to talk about today? Today, we're going to talk about how Power BI query thinks. We're going to take the mystery out of streaming and query folding. Ben is going to do it. He will start in a moment. And next meeting, those of you who are new, what do? We meet usually on the first Monday of the month, except the next month because of 4th of July. So we're going to switch to July 11. And then we're going to have someone from Microsoft coming in and telling us about something that I don't know what's going to be yet, but I'm sure I'm going to find out pretty soon. And I'm going to let you know. I'm going to create an event. Ben, the floor is yours. Thank you so much for doing this.
Hey, it's my honor. Thank you all for being here. Let's get going. If by the end of this session, you understand the following let expression, our time together will have been successful. Now, even if you're not super familiar with M-code, you can probably look at this and figure out that data is fetched from somewhere. You see source equals get data, and then that data is filtered by calling the function table select rows to filter it down to those rows where the code equals 50. And then at most 3 of those rows, the first 3 are grabbed and returned. There we have it. Thank you for coming. Have a nice evening. Just kidding, of course. Because you see, what I just walked through is a valid explanation or understanding of this let expression. But there's a lot more behind this expression than meets the eye. In particular, there's how Power Query thinks about it. Now, does that perspective matter? After all, if this expression runs and it produces the data you're looking for, isn't that enough? Well, maybe. But what about when it acts up, when it doesn't perform the way you want, when it doesn't produce the data you want? When you are stumped as to why an expression isn't behaving how you expect, it would be sure very helpful to understand how Power Query thinks about that expression. If you understand that perspective, you're much better positioned to debug problems and to write expressions, mashup expressions that perform efficiently. So we're going to have some fun. Right there. Just a little introduction. I'm Ben Gravato. Here's a picture of me from quite a few years ago, seated in front of those computers at my dad's work. I don't even know I could read yet, but I knew I wanted to do something with those computers. Over the years, that's led to being a developer, data engineer, and an architect. I work as an independent consultant. And one thing I've noticed is that if you work with people that have data, they tend to want to report on that data, to derive business intelligence out of that data. As I'm sure many of you, most of you, are well aware. And so for me, eventually that brought me into contact with Power BI and Power Query. When I started with Power Query, you could go online and watch a tutorial or read an article on many different topics if you are looking for information on how to do something particular with Power Query. But there wasn't very much out there to give you a holistic overview of the M language, the language at the heart of Power Query. And so to make a contribution in that area, I began writing the Power Query M Primer series, which is a very in-depth systematic walkthrough of the M language and related Power Query concepts, and it's available for free on my blog at bengarbato.com. I also teach a course, a live web-based course on the M language. Unfortunately, it's not free, but if any of you were to choose to sign up this week, there's a special discount available for you. But enough about me. You didn't come here today to learn about Ben Garbato. You came here today to learn about how Power Query thinks. Our focus during our time together will be built around two key thoughts: streaming and query folding. But before we get to those thoughts, we need to lay a foundation. We'll focus on two foundational concepts as we do that. One is that M is partially lazy, and the other is that an M, a value once computed, is immutable. Now you notice that asterisk after immutable. We need to explain that too. That's coming. After we've laid our foundation, built our key thoughts on it, then we'll come to some practical points. How do we take the theory we've learned and apply it to what we do day to day as we craft Power Query mashups? Let's get going. Is partially lazy. In laziness, while in life it's usually a bad thing, or always is a bad thing in the technical realm, usually it's a good thing. It implies that the technology attempts to avoid unnecessary work. It's going to try to avoid doing work whose output isn't needed. And by being lazy like this, it's more efficient. Let's jump back to the let expression we started with. If you're not familiar, in Query Editor, when you click drag and fill in boxes behind the scenes, what's being written is M code. You can see this M code by clicking Advanced Editor. And you might see something that looks like this. We walked through this expression a moment ago. But turns out, while the way we read it made sense to us, it's not how Power Query, it's not how the mashup engine, which is the component in Power Query that processes your M code, actually sees this expression. You see, we read this sequentially from top to bottom, one line at a time in order. The mashup engine sees this in not sequential order, but dependency order. That is, it starts by determining what you're asking it to output. And then it walks backwards from there to figure out what it needs to do to produce the requested output. In the M language, a let expression's output is defined by the result clause, that bit of code after the in statement, which here is a reference to variable first3. So when the mashup engine encounters this let expression, it starts at that result clause. It sees that it's being asked to produce the value identified as first3. So it says, well, where is that value defined? It traces it or steps back to where it is defined, sees that it's defined as the result of invoking function table first in on filtered. Well, where is that defined? Over here. Tracing the dependency, we can find its definition, its table select rows over source. And where is that defined? Up here. It's defined as the output produced by invoking the function getData. So here we've traced this expression, or we've looked at it in dependency order. And we've come to exactly the same understanding of how this expression works as when we read it sequentially from top to bottom. We also haven't seen any laziness at play. So what's the point of dependency order? Well, let's shuffle things up a bit. Let's keep the same 3 variables, keep them defined the same way, just change their order in code. Now, if we were to read this expression from top to bottom sequentially, it would make no sense. But if we trace the dependencies, it makes perfect sense. And this is how IM, or the mashup engine, sees IM code. Not in sequential order, but in dependency order. The order you define your variables doesn't matter. It's going to walk the references to figure out what it needs to do to produce the requested output. Now you say, but Ben, that's great, but I thought you said that M is lazy, or at least partially lazy. And we haven't seen any work avoid it. True. Let's change that. Let's revise the result clause here from referencing first 3 to referencing filtered. Now trace the dependencies. Filtered depends on source, but first 3 isn't needed. The mashup engine won't evaluate the expression defining variable first 3 since its output isn't needed. In M, let expression variables are lazily evaluated. This same paradigm applies to records as well. Here's the equivalent record to the let expression we saw a moment ago. Field first 3 isn't needed, so its expression won't be evaluated. Why should M waste effort computing a value that ultimately isn't needed? Now, bonus. The let expression we've been looking at and the record we saw just a moment ago look extremely similar. In fact, not only are they similar, but you could view the let expression on the left as basically a syntactical shortcut for the record on the right. In other words, a let expression is basically an implicit record expression, which means that if we learn something about how a let expression's variables work, what we learned equally applies to a record's fields, because behind the scenes, effectively, they're one and the same, and vice versa. If we learn something in our journeys about how a record's fields works, well, the identical concept applies to let expression variables, because again, behind the scenes, they're one and the same, just manifested or exposed using 2 different syntaxes effectively. I said that M is partially lazy. Partial implies that it's not always lazy. A principal exception to M's laziness is function argument invocation. Here, the let expression's result clause invokes function do something. Do something is passed as its arguments, the values identified as A and B. Now, in order to evaluate or run this bit of code, the mashup engine will first compute the values for A and B before it invokes or runs function do something. So the mashup engine is going to call service A and call service B, and then pass the 2 values that result into do something. If we look inside do something, it randomly picks one or the other of its parameters as the winner, and it throws away the losing value. So we've called 2 services, which, these are like normal services. They're located somewhere else on a server, which means there's latency involved as things cross the network, and service costs can cost money. So we've called 2 services, but we only ever use one or the other of those values. Is there a way we can change this behavior? M is eagerly evaluating these function arguments. We'd like it to act a bit more lazily. And the answer is absolutely. Let's just change or shuffle some parentheses around to change where function invocation occurs for A and B. Now, when this revised expression is evaluated, again, M needs to compute A and B before it can invoke function do something. But now A and B are not defined as the values produced by executing or invoking function call service A and call service B respectively, but rather just references to those uninvoked functions. So those references are computed and passed into do something. Do something determines which of those references, either A or B it wants, which one wins. And then and only then is function invocation performed. We see that then A parenthesis parenthesis else B parenthesis parenthesis. Again an M. M is partially lazy, a principal exception to that laziness. This are function arguments. M evaluates function arguments eagerly. But if you want to change that to a more lazy-like behavior, move the computing of those arguments, move that logic, move the necessary invocations inside your function body as we did here. This brings us to the second of our foundational thoughts, that M is immutable, or that in M a value once computed is immutable. Here we have a let expression. Again, this one returns a two-field record. Now, assuming that the consumer of this expression reads both fields, how many times will the value for amount, its expression, rather be invoked? Let's just look through this here. Amount is defined as the result produced by invoking function getAmount. Both fields in the record reference amount. How many times will getAmount be invoked? Let's walk through this. Let's imagine that the mashup engine decides to come up with the value for regular unit cost first. It sees that record field's expression references amount. It finds where amount is defined. So it invokes function getAmount. Let's say that the value 15.25 is returned. The mashup engine then takes this value, saves it into variable amount, and then returns it. And for each reference to amount during this query's evaluation, that saved amount will be returned. Function getAmount will be invoked one and only one time, even though here amount is referenced more than one time. This means that not only are we saving resources by only evaluating getAmount once, but we're also ensuring that each reference to amount gets the same value because that value has been immutably saved into variable amount. And this behavior holds true if getAmount raised an error. That error would be saved into variable amount and then re-raised each time that variable is accessed. In M, a value once computed is immutable. And of course, since we know that a let expression's variable is behind the scenes equivalent to a record field, then this rule applies to record fields as well. Now, there is this asterisk by the word immutable. What I've described is true, but there's more going on here than meets the eye. And this provides us with a segue to the first of our two key thoughts. In M, certain kinds of values are streamed. Now, based on what we've discussed so far about M's immutability, it would seem that variable source is going to get populated with a fully materialized table of data containing all of its rows. And then table select rows is going to filter those rows down to those where code equals 50 and output another table, a fully materialized table with a full set of rows, which is saved into variable filtered. This table is going to be accessed by table first in and filter down to yet another table containing at most 3 rows, full rows, which is going to be saved in the variable first 3 and then returned as the output of this expression. Now, what I described technically could work, and it would produce the desired output. Thankfully, though, it is not how Power Query works. For comparison purposes, let's take what I just described. Let's call it the simplistic approach. And let's consider a couple downsides with it. So with the simplistic approach, after the mashup engine walks the expression in dependency order, it determines that the first main piece of work it needs to do is call get data. So with the simplistic approach, it would do that and get back all the rows and save them to variable sourced. Then the code in filtered, the table select rows there, would access source, create another table, fully materialized, saving all those rows into variable filtered. Then the table first in and first 3 would access table filtered, create another table containing at most 3 rows, and save it into variable first 3 and return. That is the output of this expression. Can you see any downsides with this simplistic approach? Well, one downside is that we have to have local resources to hold all rows from source. That is, the system that we're running this Power Query on needs to have sufficient resources to hold all rows from source, which could be a problem. What if source contains billions, trillions, or even more rows? Well, first step is to get them all and hold them, persist them, stick them in memory, something, hold them locally. If we don't have enough local resources to do that, we cannot evaluate this expression. So with the simplistic approach, we're potentially using a lot of local resources, and those local resources could significantly constrain our ability to work with large data sets. Another downside, how many rows will we be outputting? Well, at most 3 rows. It's possible that the 3 rows we're looking for are found in the first few thousand rows fetched from source. But with the simplistic approach, there's no short circuit or shortcut mechanism where somehow it can be identified that we've fetched enough rows to provide the 3 we want, stop pulling rows from source. No, with the simplistic approach, query evaluation is linear. First, you have to get all rows from source, then you have to filter them all, and then you grab at most the first 3. There's no short-circuiting work when enough upstream work has happened to make downstream happy. Again, this is not how Power Query works. Thankfully, it's not. Instead, Power Query uses a concept, a paradigm known as streaming. With streaming, values, once computed, are immutable, as I've already said, but what's immutably saved is not a fully materialized table containing all rows, but rather a programmatic construct representing a table. And inside that construct is a handle, if you would, that promises that when it's accessed, it will produce the promised rows on demand. You know, when behind the scenes code starts an enumeration using that handle, it does whatever is necessary to produce the desired rows. So the expression, the values are still immutable, they just don't contain fully materialized rows. Let's take a look. This is called streaming again, and it is how Power Query works. So with streaming, the data flow starts from the opposite direction. It starts with the consumer of the output of the expression taking the handle that it receives and starting an enumeration of rows, and then asking for the first row to be sent to it. So the consumer asks the code in first 3, the table first in there, to say, please give me the first row. First 3 says, I've been asked for a row. What do I need to do to produce a row? I need to ask my upstream for a row. And so it turns around and asks the table reference it holds to the output of table select rows for a row. Table select rows to produce the requested row turns around and asks its upstream the output of get data, that table output from there for a row. Get data does whatever it needs to do to produce that row, and it is streamed to the code and filtered to the table select rows there. Which or who tests that row? In this row, it passes the predicate, it passes the test because its code equals 50, so it's streamed on up to the first in and table in verse 3 here, and it's streamed on out to the consumer. The consumer turns around and says, may I have another row, please? And this request flows back upstream. Source produces a row, streams it to filtered. This row, its code is not equal to 50. So the table select rows throws it away. However, select rows still has an outstanding request to produce a row of data. So what does it do? It turns around and asks get data for another row, which is streamed to it. Thankfully, this one has a code of 50, so it passes the select rows test and is streamed to the table first in and first three and streamed on out to the consumer. In this flow of request percolating upstream and rows being streamed one at a time between steps, downstream continues until no more rows are available. So why might this happen? How might this happen? Well, it could happen if the consumer of the output of this expression has asked for 3 rows and received 3 rows, and then asked for a 4th row, says, please stream me a 4th row. Well, when table first in receives that request, internally it checks and says, I've streamed out 3 rows. I'm configured to only return 3 rows. I've done all I'm supposed to do. And so it turns around and signals back to the consumer of the output, no more rows. And the consumer of the output knows to stop asking for rows. This a situation of running out of rows or being told there are no more rows could also occur if the consumer of the output is asked for a row and there isn't a row and source available to satisfy that request. So let's say the consumer of the output asks, we saw the first row and the second row were successful. It asked for the 3rd row. Table first in asks filtered to produce a row. Filtered asks source for a row and ask for another and another and another. And none of them satisfy the code equals 50 test. And so eventually, after all rows have been checked, downstream will get signaled to being told there are no more rows. This is how IM works. Streaming. You notice 2 things. 1, rows flow between functions one at a time with streaming. Now, this does not mean that a given function only ever works with 1 row at a time. Table first in and first 3 only ever touches 1 row at a time. Table select rows and filtered only needs to touch 1 row at a time. But get data, well, it might actually work with more than 1 row at a time internally. Think about a typical web API. Typically, you don't fetch rows 1 at a time, you fetch a page of rows. So when get data is asked to stream out its first row, quite likely it asks its external upstream source for a page of rows, then gets this page back, streams out the first row and buffers the rest in memory. Then when it's asked to stream out a second row, it reads it out of its buffered page and streams it out and so on and so forth until it's streamed through all the rows in its buffer, in which case it turns around when it gets another row request and asks its upstream for another page and repeats the process. So it's not that with streaming, we only ever work with 1 row at a time, but rather with streaming, each step, each function only works with as many rows as it needs to at a time, which sometimes is just 1 row at a time and often is not all rows. So we avoid or significantly reduce the 2 downsides that we saw with the simplistic approach. 1, we don't necessarily need to fetch all rows and store them locally. And 2, when we have enough data to produce the desired output, to do what needs to be done, the process can stop. In IM, table data, as well as list and binary data, is streamed. For stream data types, the construct representing the stream value is immutable. The handle it contains is immutable, but the actual data, the table rows, or in the case of list, the list items, or in the case of binary data, the actual bits, are produced on demand. They're not immutably stored in the table, list, or binary construct. In IM, a value once computed is immutable. Now, you're happy about this. It's much better than the simplistic approach with its significant downsides. You're happy about this until a friend of yours who's a data expert, a database expert, stops by and says, well, I'm glad that with streaming, we're not spending all these resources trying to hold all the rows, and it's more efficient than the simplistic approach, and so on. But you potentially have to stream a lot of rows to produce the output requested by this expression. If we were running this right on the SQL server, we'd write SQL like this. And thanks to in-memory paging of data, indexes, and similar efficiency mechanisms, the 3 rows of interest could be produced almost instantaneously. Whereas with streaming, you might have to stream all rows from source to come up with the 3 you want, or find out there aren't 3 there like you'd like. So does this mean that when we're working with large quantities of data and efficiency matters, that we should just handcraft SQL and then wrap it in some boilerplate IM code? Just enough IM code to get Power Query to evaluate the SQL that we wrote? Well, thankfully, the answer is not necessarily, because in IM, in Power Query, there's a concept called query folding. Query folding takes the IM code you write and may rewrite part or all of it into a native request in the language of the external data source. And so with query folding, an expression like what we see on the left may, behind the scenes, be rewritten into something effectively equivalent to what we see on the right, giving us, in essence, the best of both worlds. We wrote Power Query, we wrote IM code, but it was processed with the efficiency of a native query executed directly on the native external data source. This is pretty exciting. Now, it is tempting to think of table data as either being streamed or query folded, but I'd encourage us not to consider it that way. Table values are streamed. It's a complete thought. It may be that the table value that's being streamed, the code producing that table value, was rewritten as part of query folding. So it's not streaming or query folding, but it's streaming. Possibly what's being streamed was written using query folding. Let's take a look. On the left, we see the let expression we've been looking at with an addition, a table add column call. Now, let's assume that, like before, variables source filtered in first 3 query fold, but the new add column step does not. What happens? Well, behind the scenes, IM rewrites this expression to something approximately equivalent to what we see on the right. The same query folding, the same native query and boilerplate IM code is there. And then the output of that query folding rewritten code is going to be streamed like any other streaming situation to table add column. So it's not streaming or query folding, but it's streaming for table data. It just may be that the expression that's being streamed was edited or rewritten by query folding. So far, so good. Until your data friend stops by again. This time the expression is different. Instead of one source being involved, there are two sources. Here we see that rows from A are having their ID column checked to see whether it corresponds with a value in B's column filter ID. Now, assuming that A ID is a primary key and B filter ID contains 4 values, we know that this expression will output at most 4 rows of data. Now, in order to do that though, that is Power Query, will need to pull all rows, stream them all from source to check to see if they correspond. They pass this filter ID test. At least that's what's necessary if streaming is taking place. And from what we've learned so far about query folding, it may not seem it's going to help us here because we're using 2 different sources and you can't write one native query that talks to 2 sources. So, as your data friend points out in the friendliest possible way that if you were to handcraft SQL here, well, what would you do? You'd first get the 4 IDs of interest from B and then write them into the SQL that you send to A. You'd write SQL like you see on the left here. You wouldn't pull all rows from A. You would tell source A, here are the IDs I'm interested in, and let it use things like indexes and in-memory paging of data to very efficiently find those 4 rows and send just those 4 rows across the wire to you. Again, does this mean in situations like this, we need to fall back to handwriting our native request? I've got good news for you. Thankfully, not necessarily. You see, Power Query's query folding can do what we just described. It may probe the sources, determine that B contains a very small set of IDs, and then take them and rewrite them, not rewrite them, but write them into the query it sends to A. So it can come up with a query with the efficiency of what you see on the left without you having to do it by hand. This is very exciting. Also very dangerous, at least could be very dangerous. See, what if the 4 IDs from B are not the benign numbers 1, 2, 3, and 4, but are credit card numbers? Maybe A is a publicly accessible service run by a third party that contains compromised credit card numbers. And B is a database you have, which contains credit card numbers belonging to one of your customers. Now, you're trying to check with this expression whether any of their 4 card numbers have been compromised. Hopefully none of them have been. But if query folding like we see here takes place, those 4 card numbers could be written into a query that's sent to another source. And so now your potentially 4 good card numbers are now handed off to some external entity, and who knows what they're going to do with them. Talk about a security concern. IM solution or Power Query solution to this is privacy levels, which at the technical level are implemented using the data protection firewall. Their sole purpose is to control whether data from one source can be folded into another. Privacy levels do not keep you, or not intended to keep you, from combining between 2 sources, but rather to control whether that combination takes place internally in Power Query or whether it can potentially be folded to take place externally on one or more of the external data sources. If privacy levels are set appropriately, a query like what we see on the left could be executed. If they're set differently, then the query on the left would not happen, and instead, rows from A and B would both be streamed locally to Power Query and then test it there and the output computed there without A having any knowledge of the specific, without A seeing the values that were folded back, or having values folded to it from B, let's say it that way. Cross-source folding, something very powerful, but also something with significant security considerations. Meaning it's very important for us to understand what privacy levels are and how they work, how to set them appropriately. Now, here's a test for us. I'd like us to think about this simple let expression. We have a list, and we're counting how many items are in the list. The first item in the list, its expression evaluates to an error. The second item in the list is produced by invoking a long-running, inexpensive service call. Now the question, what will happen if we try to count the items in this list? Will that count die with an error? Or will it incur the cost and time delay of the expensive long-running service call? The answer is no. Neither of those will occur. We'll simply come back and be given the total 2. You see, remember, M's lazy. M attempts to avoid doing unnecessary work. To count the items in a list, like a table, is a stream data type. It's not necessary to know what those item values are. So to count the items in this list, the mashup engine doesn't evaluate the code that raises the error or that calls the long-running and expensive service. It simply says, oh, there's 2 bins in this list, 1 and 2. I've counted them. I don't care what's in them. I don't need to know, so I'm not going to run that code. So in Power Query, this expression would complete successfully, producing the total of 2 without encountering an error and without calling this service call. Similarly, table, which has been our focus table data here, this row count will also produce 2 for the same reason. It's possible to count the rows in a table without knowing what their values are or the values they contain are. So to count these rows, that's all M does. All the mashup engine does. It doesn't run the code that raises the error. It doesn't run the code that calls the long-running service. M is partially lazy. M a value once computed is immutable. M Power Query has this concept called query folding. Great. Now, this laziness is quite important for enabling efficient query folding. Look at this expression here. We're getting data from source and then we're adding a column to it. If Power Query had to compute the value for that new column for each row before or as part of counting the rows, as part of determining how many rows there are, then query folding like what we have on the right here would be invalid because this SQL statement doesn't compute the values of the new column. But thankfully, it is a valid SQL, result of query folding, a valid native expression produced by query folding. Because to count rows, we don't need column values, and so Power Query can safely skip computing the values for those new columns and instead can take the whole expression on the left and translate it to native expression, a SQL expression, effectively equivalent to what we see on the right. M's laziness here enables performant query folding. If columns had to have their values computed, query folding like this would be invalid, would be against the rules. All right, we've had our 2 key thoughts. We built them on top of our foundation. How do we use what we've learned? How do we take it to our day-to-day data mashing up? Practical point. First one, in Power Query, order matters. Now, let's imagine that the mashup engine has taken an expression, it's walked it in dependency order, it's figured out what it needs to do, and that order is listed out here with the first thing it needs to do being numbered 1, the second numbered 2, the third numbered 3, and so forth. Ideally, as a general rule, for best performance, we will construct our code in a way so that the function calls that are foldable come first when the mashup engine computes things in dependency. So the first thing it should want to do for ideal performance is to do things that it can query fold. Next would be things where streaming is taking place, specifically streaming that doesn't need to internally buffer rows. Next would be streaming where buffered internal buffering of rows needs to take place. And then lastly, any non-streaming things like computing a scalar value would, they come last. Right, let's look at this more granularly. Here's another sequence. We have 2 foldable function calls followed by 2 non-foldable function calls. And again, this is not sequential order in how we wrote the code, but this is the order that the mashup engine figured when it walked dependencies. What happens here? Well, hopefully the 2 foldable function calls are folded. And then things are streamed through the non-foldable function calls. Very good. Now what happens though? We've changed the scenario slightly. The last operation, number 4, is also now foldable. Doesn't get folded because number 3 blocks its foldability. You see, a non-foldable operation blocks subsequent potentially foldable operations from being folded, which is why we prefer to order everything that's foldable first before non-foldable. So that way, hopefully all the foldable are folded together. And the processing then of those is offloaded to the external data source, which usually produces the ideal performance. This raises the question, if we want foldable methods to be ordered first, then when is query folding occurring? You look at the applied steps listed in Query Editor, right-click on a step. In the pop-up menu that appears, if the View Native Query step is in dark text, if it's active, then you know folding is happening. If it's inactive, if it's grayed out as it is here, well, you don't know whether or not things are folding. It could be that that step is not folding. It could be that the Query Editor UI just can't tell you whether or not it's folding. So if you right-click on a step and View Native Query is in regular dark text, then it's a pretty good guess that that step and all previous steps have been folded. If
Someone
not,
please mute.
if it's thank you. If it is grayed, if it's grayed out, we don't know. Now, Power Query Online has these step folding indicators in the applied step list, and I'm looking forward to these hopefully coming over to Power Query Desktop soon. Hopefully, these give us an educated clue as to whether the associated step is being folded. They are educated, but they are still not authoritative statements. They are informed best guesses. To determine authoritatively how much is being query folded, you need to look at the queries being sent to the native source. You may do that by going to that external source and looking at logs there. You could try doing that using the query diagnostics feature in Power Query. Either way, when you get your hands on those native requests or queries, you could look at them to see whether you see logic in there corresponding with steps in your mashup code. And kind of figure out how much of your mashup logic is folded over there. Now you say, okay, that sounds like a lot of work. Can't you just give me a list of methods that query fold? The answer is unfortunately not. You see, whether or not a particular operation that potentially could fold does fold depends on a number of things. It depends on the Power Query version being used. You might write code today and a particular operation might not be foldable, but down the road, as the mashup engine and query folding improve, maybe that operation is going to become foldable. What methods, whether a method folds also depends on the data connector. A data connector to a SQL-based data source, well, imagine that scenario. That connector, quite possibly, it would make sense for it to support folding all kinds of methods. On the other hand, a data connector to CSV files on a disk, well, there's no back-end engine, database engine running there. There's not much that can query fold, probably nothing. In that case, because the data source doesn't support folding. So not only does the answer to the question, which methods can fold, depend on the Power Query version, it depends on the data connector. And the data, it's not necessarily even a static list for that data connector, but the data connector could look at what it's being asked to fold, look at the data set you're talking to, and dynamically determine what can fold. Just depends on what's appropriate in the given situation. All this to say, there's no simple list of these methods will always fold. Instead, you may need to do some sleuthing to figure out what's going on in your particular context. Now, we said that order matters with query folding, and we looked at that in more depth. Order also matters with streaming. Here's another sequence, a sequence of 3 activities. Source, data fetch, data is being streamed through a sort, and then it's being filtered. So let's think about this. If the consumer of this expression's output requests a row from filtered, filtered turns around and asks sort for a row of data, what does sort need to do? Well, unless it knows that its upstream is already sorted, it's going to need to fetch not just one row from source, but stream all rows from source, buffer them internally, sort them, and then and only then can it stream out the first row to the code in filtered, which does filtering. Let's reorder these steps. We swap the order of sort and filtered. Now what happens? Well, both produce the exact same output, but there's a significant difference in resource utilization. Here on the right, what's being sorted has been pre-filtered. So if source contains 1 billion rows, but only 10,000 pass the filter, then on the right, the sort there only needs to buffer 10,000 rows internally. On the other hand, the left sequence, again, 1 billion rows. This time they're not filtered before they're sorted. So all of them need to be buffered internally and sorted. And then after that, they're filtered down to the 10,000 that are desired. So with streaming, order matters. We would prefer to put the non-buffering methods like table select rows, which we're representing here with the word filtered, before methods that buffer like table sort. Non-buffering, but in particular non-buffering methods that reduce the quantity of rows being worked with, like table select rows does here. And it's for resource management. We'd rather buffer less rows. So by filtering out rows first before the buffering method, we help ourselves out. We help our resource utilization out potentially significantly. So the question comes, when streaming's in play, when is a method buffering? Well, if you hop into Power Query Online and look at a query plan, by nodes in that plan, you may see labels like we see here. Now, the verbiage used in query plan is different than what we're using here. What I've called buffering, it calls full scan, and what I've called non-buffering, it calls streaming. So Think of it conceptually that table rows flow between functions one at a time, streaming, whether or not a full period. When they say full scan, what they mean is that that method has to stream all rows from its upstream before it can output. When they say streaming, they're meaning that this method can process one row at a time. Doesn't need to first stream them all. Now, unlike query folding, with streaming, you can generally look at a method, understand how it works, and then deduce its behavior, to deduce whether it buffers or does not buffer. If the method only needs to touch one row at a time, it's a non-buffering method. If the method needs to work with all rows to produce the desired output, it's a buffering method. Table select rows, table add columns are by default non-buffering. They can work with one row at a time. Table sort or a table group by doing a global grouping would be buffering methods. And table join, well, its behavior can change. It can be buffering or non-buffering depending on the join algorithm being used. So although I don't know of a ready references that list out which methods buffer versus which ones don't, here, unlike query folding, we can usually deduce that simply by understanding how the method works. All right, here's the sequence we saw a moment ago. 2 foldable methods, a non-foldable, and then again, in dependency order, lastly, a foldable operation. What if we failed? What if the ordering we see on the right is possible? It would produce the same output as what we have on the left, but we just missed getting it in that order. Well, it turns out that sometimes Power Query helps us out here. You see, Power Query has an auto optimization process. If it determines that our expression could run more efficiently if it were rewritten, and if rewriting it wouldn't change the output that it produces, it may behind the scenes rewrite our expression for us. So we wrote what's on the left, it might rework it into what's on the right, which would achieve optimal folding. Again, the key is it only does this if its optimization doesn't change the output that's produced. Now, all this said, if you follow the general principles we talked with, foldable first, streaming, non-buffering second, streaming, buffering third, and then the rest fourth, that's the recommended practice. This here, though, can help you out if you overlook something, if you forget. I wouldn't rely on this to make your code perform good, but it may help you out and make your code perform better, covering you for perhaps for something where you missed it. So Vim, order matters, but sometimes Power Query helps you out. And this auto optimization, by the way, can take place even when no external data source or query folding is involved. It's a pretty neat feature of Vim. A couple gotchas to be aware of. One of those is restreaming or multiple iteration. Here we see a simple let expression. It returns a 2-item list. Each item in the list is defined as the sum over column amount of source. Now, assuming that the consumer of this output reads both list items, it would seem intuitive to us that those two sums would come out to be exactly the same value. Computing a sum, both compute a sum over the same column, we should get the same value, right? Well, not necessarily. Remember, table row data is produced on demand. Each of these sums starts a separate enumeration over column amount. If after one of those enumerations reads a value out of amount, and then let's say that on the external data source, that value is updated before the other enumeration, in the moment of time between the first enumeration, the first sum's enumeration, reading that value, and the second sum's enumeration, reading that value, these two sums could come out to be different values. Now, in this contrived example, there's a simple solution to this. We could define another variable, say called total, and define it as list sum over amount, and then just reference that variable twice in the list here. And that would work because the total would be computed once, and then it's a mutable value used for both items in the list. Now, you might say, but what's the point of this contrived example? We probably aren't going to ask for the same sum twice. And you're right. Normally we don't. But we might write other code that performs multiple enumerations of the same data. But where it's not so obvious if those enumerations touch different values. What if we did a list sum and a list average? Well, normally a sum and an average won't equal, so we'd get output here, but we probably aren't going to notice or have a practical way to notice if whether those two enumerations occurred over the exact same values or if some changed in the meantime. Is there a way we can solve this? A more generic way, because with two different operations, one variable doesn't help us. There is. We can buffer values. Here we've introduced a new variable, and it's defined as a list buffer over amount. And our two sums now reference buffered. So what happens is when the first enumeration of buffered starts, one of the sums is evaluated, and it starts requesting rows from buffered. List buffer fetches all rows from its upstream, or all amounts from its upstream, and buffers them internally. And then that buffer is used to satisfy any reference to the buffer throughout the duration of this expression's evaluation. So these two list sums will stream out the exact same rows because both of their enumerations are going to read rows out of the buffer. This is great. It does bring resource utilization things to think about, because you have to have the resources to buffer the requisite data, but you're in control. You can decide when this situation is a concern to you and introduce buffering to address it. Now, sometimes though, Power Query helps you out. It has something called the persistent query cache, where it monitors the outbound native query requests, the requests that it's sending to external data sources. And when it sees one that it's sent before, if it has the results of that external request still around, it might choose to intercept the request and satisfy it out of its cache. This cache is not caching the output of im expressions, it's just caching the output received from external data sources. But it can help significantly in making things more efficient and in producing more stable result sets. The specifics of the query cache can differ across host environments, but in production situations, the query cache only lasts for at most one refresh all operation. So the query cache could be shared between multiple inquiries or across multiple inquiries within one refresh all operation, but it's not going to be shared between a refresh you do today and a refresh you do tomorrow. Not in production. Now, in query editor in development mode, it certainly can be. And this is why in query editor, you'll sometimes see that toolbar across the top of a result grid saying this preview may be X days old. Do you want to refresh? That's a long-lived persistent query cache in play. The last gotcha to draw our attention to with query folding. Query folding is based on the assumption that logic folded to a native request and handed off to external source will be evaluated, will be run exactly the same as it would be if Power Query, if the mashup engine ran the equivalent im code. Here's an im expression, filters source down to those rows where first name equals Joe with a capital J. This is processed locally by Power Query on a table that contains Joe with a capital J and Joe with a lowercase j. Only Joe with a capital J will match. If it's processed using query folding, we come up with SQL likely like the following, and it looks appropriate. First name equals Joe with a capital J, but we might be surprised to get back Joe with a capital J and Joe with a lowercase j. And why is this? Well, because often in the database world, case sensitivity is configured on a potentially as granular as a per column basis using collation rules. And often the default is that column text comparisons are configured to be case insensitive. So even though the SQL fragment we see here is an accurate representation of the M code that was query folded, the database server is configured to process it in a case insensitive way and does so, which is different than how M would see this, the equivalent M code. So sounds a little bit scary. It sounds like query folding must be terrible. But thankfully, though, the bark here is not nearly as bad as the bite. That differences like this, while they can occur, they don't cause trouble nearly as often as you might think. But it is something to be aware of, that whether it's an equality comparison or another operation being query folded, sometimes there can be subtle differences that can even sometimes go unnoticed when between query folding and when query folding is not in play. And even since query folding can change based on changes on the data source or changes to the Power Query version being used, it's possible that code you wrote today could query fold differently tomorrow or next week, leading to differences in output like this. If you'd like to read more about this, if you hop over to my blog, there's a pair of posts on equals is not always equivalent. Just in general, we talked a lot about tables and query folding. The Power Query primer goes deep into how query folding works, even walking you through how you might implement query folding if you were building a data source, an exercise which can be very helpful in understanding the behind the scenes here. The Meet M course is also a great way to learn more here. And it's not mentioned here, but we'll leave it at that. So thank you all for your time. I hope this has shed some light on some of the inner workings of Power Query. And I hope that enables you to write more efficient mashups that produce the results you expect. And when things don't perform or work the way you expect, giving you a solid foundation, which you can use to delve into why.
Thank you, Ben. That was awesome. I want to open it to some questions if you guys have any for Ben. Anything to ask him, Power Query or beyond? Now is the time. Let's see.
And while we're waiting, I'll throw one other.
Sure.
I mentioned privacy levels a while back.
Sure.
Drop a link here. It's a simple concept that can be confusing or hard to get right. So there's a link for further reading on privacy levels as well. But yes, please, questions. I would love to.
Got nothing in the chat window. Anybody, any questions?
I have a question. I come through Power Pivot, so I'm a Power Query kind of nerd. I find that my SQL friends, we kind of go back and forth trying to figure out which is more optimized, if you use SQL or do you use Power Query. Old habits die hard, so I'm a Power Query fan, and I will be surprised to be swayed, but I will admit if I'm wrong. So what do you think is more optimal, is just from an output perspective in Power BI?
I'd say it depends. So you write some code in Power Query, whether you're doing it in the UI or by hand, you have this code. Take a look at how it's query folding. You know, if it's not, well, first let's step back. Is performance a problem? If you have an expression that runs in 5 seconds, probably not. We don't need to sweat over it. But when we start to see longer run times and we start to wonder, then look at how Power Query is query folding what you wrote. If it's looking like, if it's producing the ideal SQL for you, you're great. I mean, maybe you have to live with the runtime that you're getting, or maybe, you know, something needs to happen on the database side, like an index being added. If it's not producing the desired, you know, an ideal native query, like an ideal SQL statement, then are there things you can do to optimize your Power Query? Reordering steps, changing how you get it to achieve the output you want that produce the desired query folding. If that does not produce satisfactory results, then maybe you would want to look at writing by hand the appropriate SQL and having Power Query evaluate it, wrap it in some boilerplate code.
Yeah.
Now, one thing though to keep in mind about query folding is that if we can get things where query folding works well, we potentially get an advantage that's hard to achieve with native SQL or takes more work to achieve. So imagine this scenario. You have 3 Power Query expressions, query 1, query 2, and query 3. Each of those produce different output, but all of them reference parent query. Now, in parent query, so let's think, so when im runs query 1, mashup engine, it query folds based on what query 1 plus parent query do. And it might come up with very different SQL than what query 2 plus parent query need and what query 3 plus parent query need, which is great. You want the SQL that's appropriate for the context. Whereas if you in parent query say query folding's not working here, I'm going to replace my 50 steps here or 20 steps with the hard-coded SQL statement. Well, now everything gets that hard-coded SQL statement, whether or not it's appropriate, whether or not it's ideal in that situation. So if we can construct things so that query folding can work and work well, then im can adapt what it query folds to the exact context of what we're doing without us having to create, all these derivative hand-coded SQL statements. So I'm not saying never write hand-coded SQL in Power Query, but I would suggest not making it the default. Hey, if I can get Power Query doing what I need, great. Does that help at all?
Yes. No, that was a good answer. I need to go back and look at my M, but that's the answer I was hoping for.
So Ben, let me just continue on that theme a little bit and just pick up your brain. So let's talk about the data flows, which are also Power Query based. So I've seen some clients actually running in performance issues, and to best of my knowledge, there isn't a way to figure out what's going on there. It looks like there isn't any profiling or anything like this. Do you know, I guess the question is, do you know of a way to get a little bit more insights about what's happening in the data flow, where the time is spent and all that?
Are query diagnostics available over there?
I don't think so.
Just double check real quick. That would, if you don't have that, then you're probably going to have to go back to running a trace on your external source.
And the thing that Microsoft is keep on pushing, like this feature that just came out, Data Mart, that also it's Power Query based. So Power Query, self-service ETL tool, I get it. But when it comes to troubleshooting and figuring out what's going on there, especially in the cloud, I know in Power BI desktop you have that diagnostic thing, but I don't think it's there in data flows.
Yeah, you got Query Plan, which might help you, but if not, you're gonna probably be looking at running a trace to get what you're looking for on the, see what's hitting the database server. One of the pain points of Power Query are around the deeper development tools. To give you good, easy to use visibility. There's not a stepwise debugger. Even the execution plan you're seeing, it's not necessarily what got ran, it's what Power Query might run. And that's even complex because where you might think Power Query would do one call to source, it may end up doing several different derivative calls to source to come up with what it wants. So there's a whole lot of complexity behind the scenes. My hat's off to the Power Query team for coming up with a solution where many people don't need to touch that complexity or know it's there. But when you do, the level of effort involved gets much higher. It's performance tuning Power Query is a combination of art and science. And what on data flows, just jumping back to something you mentioned, if I could, at the very beginning, you're wishing to go to SQL, to an arbitrary SQL database from data flows. You're talking about Data Mart.
So that was actually the Data Mart. So
Yes.
Data Mart, the way it
Mhm.
works right now is that Microsoft
Mhm.
kind of provisions a database for you. They manage it. It's a read only for you. You
Mhm.
cannot create views. You cannot do anything like
Mhm.
that. That's what I was referring to.
I think, were you hoping that eventually you could just say, pick your own database, bring your own database?
So to me,
Mhm.
and again, I'm maybe too critical of Microsoft, but all of these pure self-service BI features, I just seen a lot of cases where they just don't work so well,
Yeah.
and organizations get bought into that, and then eventually they just fail to deliver. But what I thought would be very, very useful is that, you know how in data flows basically save output into CDM folders. I mean, that's the only destination. Really nice if you can actually have a destination in Power Query where you can say, I want to save the data into any connector that we currently support. If that was the case, this whole thing about the data mart actually becomes a new data point, because it doesn't matter who sets it up. IT can provision it if they want to have control, but then they can say, oh, users help with the self-service ETL, go and create data flow and say, kind of put it into that database that we're going to provide. That would have been a killer feature for me, and I'm not sure why they're not doing it.
Yeah. Some of that's coming.
Oh.
Arbitrary SQL destinations, SharePoint CSV, and data lake are coming. But yeah,
Cool.
I love the generic thought you're saying. If you could pick a destination, then you can put it where it works best for you.
Absolutely. And we have a
Great.
question here to somebody from Joseph. Does query folding work with SharePoint data sources? SharePoint performance with queries can be horrible. Admittedly, might be from the transformations I have in the steps. So the question is, do we fold when we query SharePoint?
I don't believe SharePoint supports folding.
Yes, I agree with you. Here's one tip that I want to give to the audience, and this came from, again, experience, not with SharePoint all that much, but with Dynamics, which it's a very common Dynamics CRM now called Dynamics Online, obviously very common source. And that one forces you to go through APIs. Actually, you can stage data to data lake, but that actually has other issues. But if you go through APIs, then the performance is horrible. So have a client actually downloads a few million rows from Dynamics in Power Query. Initially, when we look at that, performance was horrible. And the way to, well, APIs are in general very slow connector. It's nothing to do with Power Query, it's just Dynamics itself. It takes a while to actually send the results. But what can help you, and I'm not sure if SharePoint can do that for you because I haven't looked at behind the scenes what it does. For Dynamics, the API calls support syntax where you can specify filters. So instead of bringing all the columns from a table, and instead of doing filtering inside Power Query, in which case what's going to happen is that we're going to download the entire data set before we apply a filter, you can actually do that on the REST API call. So if you search for REST API filters, you will see. So basically, in this case, what you do when you send that API query to the source, you can actually ask that source to pre-filter the results before they come to Power BI desktop. That makes sense.
Yes, and that's where I don't know what SharePoint's capabilities are in that realm, but if it doesn't support that or doesn't support much, there's no way for Power Query to do any better. So going back now on Dynamics, though, I'm glad you mentioned that. That realm has been changing because with Dynamics Online now, the Power BI connector can hit SQL behind the scenes.
Yeah, that SQL.
Yeah.
Had a long discussion with Microsoft about
Yeah.
this. They implement something called TDE endpoint, but that one has a lot of limitations on scalability. What they've done
Mhm.
it, the way they implement it is for direct query. It's just that from performance standpoint, there is a lot of things in there.
Yeah.
And I would argue, what I argue with them is that, why don't you give direct access? Because behind the scenes in Dynamics, we have SQL database. So that has been a kind of a mission of mine to see how many actually providers will actually give direct access to their database, because to me, there is no good reason from engineering standpoint not to give direct access, but have to stage to a data lake, has to go through APIs. All of these things just horrible ways to get the data. That's, sorry, just venting out. Cool, guys. Why is the data lake route not preferred for Dynamics? Okay, all right, now we're going. James is asking, Theo, let me get you here. Why is that not a good? Okay. Because what Microsoft has done, and the same applies to data flows, is that they save the results when they stage to a data lake, they stage it into a proprietary format called CDM folder. Well, proprietary, it's not that proprietary. I mean, you have the specification. But the way they save that data is in CSV files. There is a JSON file that actually defines the schema. The problem is that not many sources out there, not many tools support this format, number one. And then talk about query folding. Number two, what about, let's say, if you dump like several millions from Dynamics into a data lake, and now I want to read only the data for the last year. Guess what? It's not going to happen because there is no data folding going to a data lake. And back to the question, why Sharepoint doesn't support. To my knowledge, only relational databases support query folding. So you're talking about Oracle, talk about SQL Server, and pretty much that's it. Only a small subset. You send this to a data lake, there is no way to do query folding. You send it to Sharepoint, there is no way to do query folding. So getting data from a perfect store, which is a relational database, and putting it into a flat files, it's a bad idea. Only probably to get it back into relational database, because that's where you wanted that data to be. So to me, it's just not optimal. Now, Microsoft for Dynamics, they have something that they provide that allows you to stage the data out to a SQL database, but they're kind of de-emphasizing this because of staging, because the preferred way now is to stage to a data lake with all the caveats that I mentioned. Sorry.
Can I add something on that?
Yep.
Query folding, OData feeds also support query folding.
Really?
Yeah. In fact, that's one of the, yep. And then if you have a custom API, you can build, so your company offers a service of a custom API, you can build a connector that enables Power Query to query fold to it.
Okay.
And depending on how much effort you want to put will depend on what level of things can be query folded. But there are possibilities there.
Okay. Good to know.
Yeah.
Okay, yeah, James was saying, I don't know what happened to, but it was supposed to support Parquet for data lake export. Yeah, I'm not sure what that happened unless there are some new developments. I know CDM folder is the standard right now, and that's a CSV base. And also so you can use Azure Databricks with the data lake format. Azure Data Factory mapping data flows, not the copy activity, the mapping data flows also supported. I think Synapse Serverless supports it, but you see the idea. You keep on adding layers on top of the architecture, which in my opinion wouldn't be necessary if you had direct access to the relational database, just like you have with Azure SQL, because behind the scenes, Dynamics saves in SQL, Azure SQL database, right? So maybe we can bring this offline. This is a subject near and dear to my heart. I've seen horrible implementations. You know, everybody wants to go to the cloud nowadays. They move their ERP system to the cloud, and then the whole thing falls apart. You know, they force you through APIs. They force you through some data lake implementations, which are far from optimal. But any other questions for Ben? Well, Ben, I think that's it. It was a great presentation. Thank you so much. We are recording it. Hopefully, that's going to bring a lot of value. I'm going to send the. Just give me 1 hour. I'll put it on YouTube, and hopefully, we're going to have you back again. Sometimes in future. We'd love to have presentation from you on data flows and this data mart thing, because it looks like Power Query is getting everywhere. So probably that will be another topic you can present on, given the Power Query focus. Have a great evening, everybody. You know, thank you for coming to the meeting. Next one is going to be July 11. I'll see you there. Have a good time until then. Stay healthy. All right, Nina. Maybe you can unmute yourself, and looks like you have a question.
Yes. Well, it's kind of question. I tried to contact you on previously. Well,